Hi, this is Chapter 1, Section 1, Describing Matter. And in this chapter, we will investigate the differing states of matter and the particles that make up that matter and how those particles behave. So way back in 3rd grade, you guys studied the differing states of matter, which are pictured here in water form as solid, liquids, and gases. Remember that matter is anything that does take up space and has mass. And we're going to study some properties of that matter, like color, texture, shape, flammability, that means can it be lit on fire or explode, and the size. We talked a little bit in class before about characteristic properties, and those are the properties of a substance that never change no matter how much or how little of a substance that you have. And I think we had the example of if I had a glacier or a drop of water, they're made of the same thing, even though they're different states of matter. So they have the same characteristic properties. And here you see that diamonds are the hardest natural substance. That's a characteristic property that never changes either. And those properties can be used to identify a substance. Some common characteristic properties that scientists look at are boiling points and melting points. And here we have pictured the boiling point and the melting point of water. And really, anything has a boiling point and a melting point. It's just the temperatures at which something boils and the temperature at which a solid melts. So if I have a piece of metal, it does have a melting point. I can heat it up enough for it to melt into a liquid. And believe it or not, we can heat it up even more for it to boil. And when something boils, it turns into a gaseous form. So really anything we have, any substance that we have, does have a melting and a boiling point. There are a couple changes that matter can go through. Matter can go through physical changes, or in the next slide you'll see chemical changes. And physical changes do not change the identity of a substance. So you see a crushed soda can. It's still a soda can, just because it changed its shape doesn't mean it's not a soda can anymore. Kool-Aid, if you dissolve that in water, we can evaporate the water out and still have Kool-Aid afterwards. Now, the desk you're sitting at, if I were to break that into 1,000 pieces, they're still pieces of a desk. I haven't changed its identity. Could I put them back together? It'll take me a long time, but I could probably do it. So it's just changing the form of a substance. It's not changing its identity. Chemical changes, however, break apart or combine matter to create a new substance. So here we see an example of a chemical change on the car. It's an example of rust, which scientists call oxidation. It's oxygen, water, and iron coming together, and that chemically changes that metal. I can't turn the metal back to what it started as. Okay, it's been changed into a new substance. Whenever you cook something, you are chemically changing that substance. If I were to take cookie dough, put it in the oven, no longer will I have cookie dough. I will have fresh, delicious cookies. I can't change it back to dough. So I have chemically changed that cookie dough into something different. Whenever you burn something or you have a fire, let's say we had a fire outside in the courtyard and we all were standing around roasting marshmallows. We could not change the logs in that fire back to wood, right? We now have ash and released carbon dioxide into the air. We can't put those things back together and create a new log. So we have chemically changed that wood. Mixtures are substances that are not chemically combined. So these things we can separate. You see on the right, you see M&Ms. We can separate those by color. Okay, they are not combined. We have ocean water on the left. That can be separated. We can evaporate out the water, and we've talked about this. And you can have salt left behind. So anything that you can separate after is not chemically combined. Pure substances are substances that contain only one type of matter. For example, gold, water. These things have specific characteristic properties. They can absolutely be mixed with other things. For example, water can be mixed with a variety of things. Think of your Kool-Aid. Think of salt water in the ocean, or even your blood. Your blood contains water. So even though water is mixed with several other things, it contains and it still has those characteristic properties that make that substance unique. We have here pictured the periodic table of elements. This periodic table contains about 118 elements. Some are naturally occurring, but we have some that only can be created in a lab setting and only last for a very short period of time. These elements are made up of really small particles called protons, neutrons, and electrons, and this is something we will study more in Chapter 3. But they are very unique from one another, and each one of these elements has specific characteristic properties that make it different from all the other elements on the periodic table. When we combine elements, we create compounds, and when we do combine the elements, they are held together by chemical bonds. So we are chemically changing these atoms. And when we do chemically change the atoms, we combine them, creating a new substance with new properties different than the ones that they had when they were single atoms. For example, water. We are taking two gases, hydrogen and oxygen. Both, if they were in their own element form, they would be gases, but combine them chemically, we create a liquid. So there is our introduction to matter. We will be looking at matter in different ways, how one thing changes from one type of matter to another one, and we call those phase changes. We will be studying the elements on the periodic table in Chapter 3 and looking how they combine to create new compounds. I'll see you in class.